Okay, here we are, stiochiometry unit video 3. We're talking about yields. So first of all, what is a yield? A yield is how much you get when you do a reaction, or when you do anything really. There's two types. There's the theoretical, which is the amount you calculate, and that's based on your limiting reactant, which we learned how to calculate in our last video. And there's the actual yield, and this is the amount you really have at the end. So like what you collect in your filter paper, what you have in your beaker, what you can put on the scale. Okay, they're similar but not the same. Let me give you an example. So I give James a measuring cup and I send him to the sink and I ask him to measure out 1 cup of water. Okay, so James goes to the sink. Theoretically, he should bring me back 1 cup, right? But he comes back and the cup is like 3/4 of the way full. So my actual yield would be like 3/4 of a cup, but my theoretical yield was 1 cup. Normally, your actual yield is going to be smaller because along the way, somewhere you lose something, you lose some of your product when you're transferring things, or maybe you didn't quite measure correctly. So normally your actual yield is smaller. So how about our example? Back to our jeans sale at Kohl's. Okay, so you go to Kohl's and you have $40 in your pocket. Woohoo! Jeans are on sale for $20. What's your theoretical yield? So you say $20 per pair of jeans. You have $40 and they're $20 for each one pair. Oh, look, unit canceling. So theoretically, you would make 2 pairs, or you would buy 2 pairs. Okay, but your actual yield, oh, you went to Kohl's, but you forgot to think about the sales tax. So your actual yield is only 1 pair of jeans. Okay, I hope you found a good pair. So why are they different? Well, there's something you didn't think of, or there's some loss along the way. Okay, so let's do a little chemistry example. So here's example 2. You have this lovely reaction. So you're reacting aluminum and copper nitrate. So if you react 3.5 moles of aluminum with 3.5 moles of copper nitrate, what's your theoretical yield of copper? So the first important thing you have to do is you have to figure out your limiting reactant. So what limits? Okay, what's your limit in this reaction? So you have to figure that out first. So if you remember from our last video, what you're going to do is you're going to start with each one and solve for how much of one of the products they could make. So which product does it make sense to solve for this one? Copper, of course, because the problem asks us about copper. So let's start with our first piece of info here. You have 3.5 moles of aluminum. Okay, so starting with that, how much copper could you make? So again, remember, you're going to go to your balanced equation. So it's 2 aluminums for 3 coppers. So you'd have 2 aluminums, 3 coppers. Okay, so you're going to calculate. And you come up with, oops, pen not working, 5.25 moles of copper. Okay, and then your next one here, you have 3.5 moles of copper nitrate, 3.5, and again, you're just going to CuNO3, okay, again, you're just going to figure out your theoretical yield, and you look at your ratio, 3 copper nitrates for 3 coppers, so it's 3 over 3. 3 coppers, CuNO3, 2. Wow, it's good handwriting. So you come up with 3.5 moles copper. Okay, so your question is, which of those is actually your theoretical yield? So you pick the one that is right. And remember, when you pick out your theoretical yield, it's the one that makes less product. So the one that made less product was right here. So your theoretical yield of copper would be 3.5 moles. And your limiting reactant, I know it doesn't ask this, your limiting reactant would be copper nitrate. Okay, so onward we go here. So again, you're reacting, I changed my numbers. You're reacting 0.035 moles of aluminum with 0.035 moles of copper nitrate. What's your theoretical yield? So this is really the same problem we just did. I see I changed the numbers though ahead of time here. So based on what we did last time, we found out that if you react 3.5 moles of copper nitrate you can make 3.5 moles of copper. So if we have, this is going to be the same thing. If we have here 0.035 moles of copper nitrate, we're going to make 0.035 moles of copper. Okay, now we're going to extend this problem here. You've done the lab and you collected 1.27 grams of solid copper. Is that an acceptable actual yield? So what you're going to do is compare what you calculated. This is your theoretical. You're going to compare that, what you calculated, to what you actually did, what you actually made. Okay, now in order to compare them, you have to have them in the same unit, of course. So let's change that to grams. So we have 0.035 moles copper. And of course, to go to grams, we have to use the molar mass of copper. Okay, and our molar mass is 63.5 grams. Oops. So you're going to take 0.035 times 63.5, and you come up with 2.2 grams of copper. And now remember, this is our theoretical yield. So theoretically, we could have made 2.2 grams, but we actually made 1.276. Is that acceptable? You lost almost a gram. I guess that would be acceptable. That's kind of a lot to lose. But yes, I would say the answer would be yes, that would be acceptable. Okay? Because you didn't make more than you predicted, and we always predict that we'll lose some of it. So yes, that would be an acceptable actual yield. What would be an unacceptable actual yield? Let's say you actually collected 5 grams. Well, that would be not acceptable. You can't collect more than you predicted. So then you know you did something wrong. Remember, it always has to follow the law of conservation of mass. Okay, so let's take this a little further here. Percent yield. So percent yield is actual yield over theoretical yield times 100. And you're just finding a percentage. So what percent did you make of what you should have made? Okay, so what's your percent yield if your theoretical yield is 0.025 moles of solid silver? Okay, and on a scale, you have 2.25 grams of silver. So again, they have to be in the same units. So put your 0.025 moles of silver into grams. Okay, you could put the other one into moles, but grams, you know, you're actually going to collect grams, so it wouldn't matter. So you have to use molar mass of silver, which is 107.87 grams, 1 mole. So you're going to multiply. Okay, so this gives you a theoretical yield of 2.69 grams. And again, that would be your theoretical, because that's what you calculated. That's based on this number right here. Okay, so now you want to find your percent yield. So to find percent yield, you take actual, which is 2.25, over theoretical, 2.69, times 100, because it's a percentage. Okay, and you come up with 83.6%. Okay, not too bad. That would be about what you would expect for a percent yield, considering you lose some when you filter or when you're collecting it, however. So that's percent yields. Oh, this is the last video of our stoichiometry unit. Okay, we'll see you guys later. Bye.